So today we're going to actually use our new function, move the distance d in a direction a. We're going to actually start drawing things using Python and Tickle TK Canvas, which I'll show you here. So the first thing I'm going to do is I'm going to move my window up a little bit so that I have room to put the canvas underneath and we can still see the code at the top. And then I'm going to, from tkinter, which is the Python version of the Tickle Canvas, I'm going to import everything. And then I'm going to create a window by setting it to the TK function. And then I am going to change the window geometry. Window geometry, it knows what that is. This is a string, and it's the width in pixels of the screen. My screen is about 1600 wide, so I'm going to do 1500 by 450, which is about half the height of my screen. I'm going to offset it 90, plus 90 in X and plus 500 in Y. 550 probably, maybe 540. And what this will do is it will put the TK canvas below my window here. You'll see that in a second. I need to create a canvas, and I'm going to do that by using the canvas function that comes with TK, canvas function. And then I need to push the canvas into the window. So what I do is I do a canvas pack. I push the canvas into the window, and then I've defined my function, so I'll get a canvas to draw on. I've defined my function, and then instead of this print at the bottom, what we're going to change this to, a main loop function. And the main loop function is going to do all the work when we create the canvas, and I'll show you how this works. So basically, it's going to do all the drawing for us. That main loop function is going to take over Python for us and do all the things that we want it to do. So let's just go ahead and try running this and see what happens. Oh, look at that. I've got a window down here. It says it's TK. It's got a gray area in it, and it's sitting right about where I want it in the screen. It could be a little bit wider, but I'll leave it there for now. So all we've done is we added a tkinter. We made a window. We pushed the canvas into the window. I can't really see where my canvas is in the window. So what we're going to do, go back here, and we're going to say that the canvas should have a background that's equal to light blue. That's a color. And so now we're going to go ahead and close this, and then we'll rerun the program. Oh, look at that. There's a canvas in the middle here, but the window's a lot bigger than the canvas. So when I pack the canvas into the window, I have to tell the Tickle to fill both the X and the Y direction with the canvas. And also I'll put in here expand equals true. And that will tell, come on, I can't type. That will tell when it gets packed in that if the window changes size, it will also change size. So let's go ahead and kill this and restart it. And now what you see is that when the canvas got packed into the window, it fills the whole thing, which is what we want. So that's great. Now, we just need to do something, right? I've got this canvas. I just need to be able to do something. So we're going to write a little function that's going to draw something for us. So we're going to define a function called draw, and it's going to take an event as an argument. I'll show you why. And we're going to draw something here, okay? So what I'm going to do is from the event, which I'm going to click in the window here, and it's going to call the function draw. And I'll show you how I do that. I do that by saying canvas, it remembers that, bind. Okay, and so now I'm going to bind button 1, and I need square brackets around the button 1, or angle brackets. So bind button 1 to the function draw. Now I don't want to make it a function like this that evaluates the function. I want to point at the function itself. So now every time I click button 1, I should get a draw. Let's just do this. Print you clicked. Okay? So let's go ahead and close the canvas and rerun this. What I'll do probably is I'll make this, give us a little bit more room. I'll move this down so we can see the canvas. So I've got a function draw, takes an event, and just prints you clicked, and I have a button 1 that's mapped to draw. So in this canvas, if I click the button, it says you clicked. Every time I click, it says I clicked. Now it turns out event X and event Y. And what will happen now, take out this parentheses. So I'm going to print I clicked space event X space event Y. And when I run this program, from the event where I click, it gets passed as a variable into this function, and I can get the X and the Y coordinates. So when I clicked at 645, 140, 56. So if I click way up here on the left-hand corner, it's 5 and 6 pixels in. It's very close to 0. So the way the canvas works is 0, 0 is up here. And down here at the bottom, it should be pretty close to the width of the canvas. We set it to 1500 and 450. So it's pretty close to 1500, 450. So I have XY coordinates in here, and I can draw lines on this canvas. So let's go ahead and do that. So instead of just printing this, let's capture the X and Y value into XY is equal to event X, comma, event Y. So we just created a tuple that's going to be where we started, okay? And we know we can call our function and get a XY2, a second point, that's equal to move D in direction. And let's say I want to move 100 pixels. I'm going to need an angle here. Let's get an angle. Let's set angle equals 0. So I'm going to move 100 pixels to the right. Angle. The starting point, which is XY. And it's going to calculate the new XY. Let me get some space in here so we can see better. So this function, when you give it a distance, I give it 100. And I gave it an angle. I gave it 0. And I gave it the point where I clicked, XY, over here. It's going to move 100 pixels to the right. That's all that's going to happen. But now I've got an XY and an XY2. I want to draw something. So what I'm going to do is I'm going to draw a line on the canvas where I say, and once I have the canvas, I can see the create line function here. I say create line, line. And what it needs is it needs the beginning and end. All this stuff tells you the beginning and end. But basically, I want to go from XY to XY2. So when I click on the canvas, I should get a line. So let's go ahead and kill this. I can hit the restart button here as well, but I'm going to click this. So if everything works and our function works, when I click here, I should get a 100 pixel line to the right. Look at that. It works pretty well. I get a 100 pixel line to the right. Well, what if we put this in a loop? So for I in the range 4, that's going to give us a number from 1 to 3. So 4 numbers, 0, 1, 2, 3 rather, right? I'm going to shift these over. And so I'm going to draw a line from XY to XY2, and then I need to set XY to XY2 because this is going to go in a loop. And so I take the XY point, right? And I'm going to draw the line in a new position by going 100 degrees at the angle, and then draw the line, and then I need to be able to change the point, but I also need to be able to increment the angle. So let's do this. Let's subtract 90 degrees from the angle. So I started 0, so then I'll be going minus 90 degrees. And so this, let's see what this does. Let's go ahead and hit restart. My function takes a minute to kill it, and it comes back. It's actually quicker if you kill yourself. So what should happen, I'm going to click the mouse, the middle mouse, the mouse button, the left mouse button. It's going to go to the function draw. It's going to get the point on the canvas that I drew. It's going to store it in this tuple XY. The angle got set to 0. And then 4 times, it's going to move 100 pixels at angle 0 from point XY to XY2. It's going to draw a line from XY to XY2. It's going to set XY to XY2, so the next line will start where I just ended. And then it's going to change the angle by 90 degrees. So when I come back in, the angle will be 90 degrees less. And what happens when I click down here, it draws a square. It went over, up, and over and back. So I get a square. Now you'll notice that there's a little jog in the lines here, right? And it's not perfectly square. We'll see that in a minute. Because what happens if instead of 90 degrees and 4, what if I did 72 and changed by 5? Now, 5 times 72 is 360. So instead of drawing a square, this should draw a circle. Well, look at that. It's pretty big because it was going 100 pixels 72 times. So to draw the circle, we want to use a little bit smaller value, maybe 10 times smaller. Okay, but notice we didn't get back to where we started from. So if we do this again, we're trying to draw a circle. And when we click, we missed. And the reason that we missed is that in our function last time, we had put in an integer function. And that integer function, we lose some accuracy as we're stepping around a circle with very small angles and degrees. So we're going to take that out. We did that just so the numbers were good when we were working last time. So now it's not an integer. Now it's actually real numbers, and so it'll calculate accurately, even though it's only integer values on the screen when it's plotting. So let's show you what happens here. So now when I rerun this program, when I click, I get a perfectly good circle. Well, that's kind of cool. Every time I click, it goes a little bit at 5 pixels or 10 pixels, turns 10, 10, 10, 10, 10, and 72 times around this loop, moving every 5 degrees, is a 360-degree circle, and we come right back to where we started. Well, since we come right back to where we started, we could put it in another loop. Okay? So let's try that. So this inner loop is drawing a circle. What if we made an outer loop? For out loop in range, let's do 36. So 36 steps, and then we're going to shift these over because we need to make these move over. This guy needs to move over as well, right? So we've got an outer loop that's going to go 36 times. When we come back, we're going to come back to where we started. So not in this loop, but here. After this loop finishes, we want to change the angle by subtract, but let's do 360 divided by 36. Okay? I'll put a .0 in here so it's actually a real number. And so now I've got 36 and 72, and then the outer loop stops. I believe. We'll see if I did that right. So I've got 2 loops, one that's going up to 36 times, the other one's going 72 times. So this draws a circle, and then this changes the angle by 10 degrees. So when we run this program, actually not yet, by 10 degrees, I click, whoa, I got a circle, and then I moved by 10 degrees and draw another circle. I ended up drawing 36 circles. So I got a very nice looking picture. Now, the problem is every time I click, I'm drawing hundreds of lines, and the canvas is getting filled up. It'd be kind of nice if we had a way to clear it. So we'll figure a way out that we can bind another button or bind to something and actually erase. We'll do that in a minute. But so that's pretty nice. And you can play with this little program and change these numbers. What I would suggest that we do is rather than 36 here and then divide by 36 here, is that we say, look, let's define at the top here, the starting angle can be 0. That's not a problem. But let's say that the distance, well, let's define counter for each of these things, and then we can change the counter value. So let's do the following. I'm going to define a global variable. We'll talk about this a little bit later. That's called how to draw. And I want to give it the distance. Let's say 100. I want to give it the number of times on the inner loop. Let's say 4. And then I want to give it the number of times on the outer loop. Let's say 1. Okay? So how to draw 10, 4, 1. And now inside this program, we're going to say D and then N in the inner loop and N out equals how, it's actually up above here, how to draw, how to draw. So we're going to unpack this array into D, N in, N out, and this is going to be N out, and this is going to be N in, and this is going to be D. The angle is taking care of itself, and this is not going to be 5. This is going to be 360 divided by N in, the number of loops inside. So we go complete the circle. We come back to where we were, and this is N out. Whoops, I got to type N out. So this is going to give us a full 360 degrees with either 4, 5, 8 steps, and then this is going to give us 360 degrees on the outer loop. And so now all we have to do is change how to draw. And this is 4, 1, and 1, so this is not going to be that interesting. This is going to give us the square again. Oops, I made a mistake. How to draw is not defined. Oh, I forgot the equal sign. I made it a function. How to draw is equal to, and I can't put square brackets here. I have to put, or angle, or parentheses. I have to put this. Now, how to draw is an array. It's got 3 elements, 100, 4, and 1. And that way we can unpack that array in this program and get a D, an N in, and N out, all from one global variable. And then we'll see why we're doing that in a minute. So now when I run this program, I get my box and I click and I get a box. Well, that's kind of cool. Now, I have to click a lot of times to draw a lot of boxes. I can draw a lot of boxes. What if I change the binding so that it's not when I click, but when I move? So what this tells the program is that when the mouse moves, any motion causes the draw program. So let's kill this. And let's run this again. So what I would expect to see is when the mouse moves into the window, it's going to draw a square every time the mouse moves. Well, that's kind of cool. Now, what if I don't want to draw a square? I want to draw something a little more complicated. I can go back up to my definition here. Instead of going 100, let's go 80. And let's go 8 times just once. That will give us 8-sided. That's very nice. And so I've got an 8-sided diagram, right? And again, I can kill this and run it again. So it seems to me that the first thing we want to be able to do is switch between clicking once and also switch the size that we're drawing. We want to try a bunch of different repetitions of 4 steps, 8 steps, 12 steps, whatever. So we need an easy way to change that. Right now, the program is sitting in this main loop, and every time the mouse moves, it is drawing this octagon, okay? We can go back in here, and we can say, look, instead of 8, 8, and 1, let's go 36. That will give us 36 of them. And I get these beautiful looking squares. I probably want that on a single click. So let's move this back to button 1. And so now I get, every time I move, that's very nice. Now they're all black. I'd like to make them colorful. Wouldn't it be nice if they were colorful? So what we can do is we can go up to the top and define, this is a global variable. You can see this global variable inside these functions. I can point to how to draw and it sees it. So we can make a thing up here called colors, which is going to be an array. It's going to be, well, let me pick a set of colors. I have a set of colors that I picked that work out pretty nicely. Let's put these colors in here. Black, red, blue, green, yellow, orange, magenta, and gray. I'll show you where the document what all the colors are you can use. So now I've got a list of colors. And so when I go down here to draw this inside box, okay, I need to pick a color. So what I'm going to do here is I'm going to say my color is equal to, and here's where you can use random. So we can say random choice. Give me a random choice of colors. So colors is an array. right? I defined it up here. There's a bunch of colors. And so it's going to randomly pick one of those colors. And then all we have to do is when we draw this line is we say we want the fill of this line to equal my color. So when it draws the line, it's going to be of that color. And all the lines, every time I click, is going to be the same color. So let's see what happens if I do that. So now, when I run this program and I click, I get different colored shapes. That's pretty cool. And if I go back to making this move on motion, actually what I'm going to do here, kids, is I'm going to hit Control D. That duplicates the line. I'm going to hit Control / which makes it a comment, so I can come back and get it later. And I can just comment these out. It'll be a lot easier in motion instead of typing all the time. I don't want you guys watching me type. So now on motion, and I'll go back to the top here, and I'll take this back to 1. And when I restart the program, as my mouse moves into the region, I get this beautiful, every octagon is a different color. Looks like a snake or something you crawl through. That's pretty cool. Well, we'd like to be able to control this and change whether it's drawing it continuously or when I click and which shapes it's drawing on the fly. So let's add some code to do that. But let's take a break for just a second, and we're going to review the code that we have. We imported tkinter, all the stuff that creates the canvas. This is the TK canvas. We set the geometry. If I move this and make this 0, it would be sitting at the top of the screen. Remember the geometry, the 0, 0 is up in the upper left-hand corner, and the big number's down in the bottom right-hand corner. We created a canvas, which actually is the canvas that you can create a line on. We set it to have a background of light blue. If we change this to black and rerun the program, then it's going to look a little different. And when I come in here, it's pretty freaking sweet looking. Not bad. Now, I'm filling the window in both X and Y and allowing it to expand. I've set a set of colors that I can randomly pick when I'm drawing. And I defined how I want to draw. It's basically, this is the distance I'm going. This is how many times I'm going to turn by an angle to make a full 360. And this is how many loops I have. Right? And then move by D in direction A is the function that we did last time. We took the integer part out. So it takes the point, the angle, and the distance and calculates the new point from the formulas that we worked on last time. And then I created a draw function that takes the point where you click, angle 0, unpacks how to draw, the distance, the inner loop count, and the outer loop count. These are a little bit awkward, so let me do this. I'm going to right-click on this thing, and I'm going to say refactor and rename it. N_N is little goofy. So what I'm going to do is I'm going to change this to, this is the inside count. Whoops, D comma, whoops, I might have lost my, I lost my inner count loop. I did that wrong. So let's do this again. Inner count, too many N's. So this inner count, copy, and that goes here. And then this out and out, I'm going to refactor this, rename, and it's going to be outer, outer count. So now it's changed that outer count here and outer count down here. I don't know if that should have 2 T's or not. Probably not. And then outer count down at the bottom. That's kind of a little weird looking. Outer, I guess that's better. Outer. So we've got the outer count, the inner count, and we're moving by D in the angle. And then we're using this equation. This minus sign equals means subtract 360 divided by, oops, looks like I missed something here. Copy, inner count. So let's make sure this thing still runs, because I screwed around with it a little bit. It came up. That's pretty cool looking. Oops, it slowed down and stuck on me for some reason. There it goes. My computer must have burped. So we've got an outer loop and an inner loop. The inner loop does 360 degrees, in this case with 8 steps. And then the outer loop is doing 1 step, and we're just drawing a single octagon, but we're drawing it many, many times every time the mouse moves. And if I go back and I do a control slash and a control slash, then when I run the program, it will only happen when I click. Let's see if that works. Takes forever to do that, right? Come on. There we go. And now when I click, I get the octagon. And each time is a random color. And that's not that exciting, so I can go back and change this to, let's do, I don't know, 36 of those. I actually find it's quicker to close the window and start it again than to do that. So now I get this very nice looking beast. All right, let's stop for now.